Hi everybody. Well, today we are going to move on from classifying triangles to classifying quadrilaterals. So this is section 9.5. Now, if you want, you can print off a copy of the note sheet and fill things in as we go. I have that linked with the video here, but otherwise you can also just take your own notes on your own paper. So we've got a few more terms to look at again. The first one, of course, is quadrilateral. We've talked about that before. You see the word quad in there. Quad means 4. Right, so it's a figure that has 4 sides. It's all in one plane, so it's two-dimensional. And each side intersects exactly 2 other sides, one at each endpoint, and no sides are part of the same line. So there's no gaps, no holes, no sides crossing each other, anything like that. And there are a couple examples for you. 4 different points, 4 different sides. All right, now we got to talk about the different types of quadrilaterals. We're going to talk about all the major categories except one for today. So the first one, after you have just a 4-sided figure, we can classify them as parallelograms. So that's a type of quadrilateral. So this is a subcategory with 2 pairs of parallel sides. And guess what? Those parallel sides have to be across from each other like we see in the picture because parallel sides never intersect. And usually, but not always, parallelograms have kind of slanty sides. And we mark the different pairs of parallel lines with different markings. All right, now we're going to add to the list of characteristics when we get to a rectangle. So a rectangle is a parallelogram. So it has all the parallelogram properties, so the opposite sides are parallel, and we add on 4 right angles, which we have marked in the picture. So that makes it a rectangle. Now we're going to move on to another category. It's also a rhombus. So a rhombus is also a parallelogram, and it's a type of parallelogram. It has 4 sides, and they're all of equal length. So notice we marked the parallel sides like a parallelogram, and now we marked all the sides with the same marking to show they're all the same length. A lot of times a rhombus will look like a slanted square. Okay, so now here we go. I'm going to flip over my note sheet, and we're going to talk about a few more terms. And then some examples as well. All right, so we've got one more term to look at here, and that's a square. So a square is a parallelogram. So it falls in the parallelogram category. 4 right angles, so it falls into the rectangle category. And 4 sides of equal length falls into the rhombus category. So the square is the most specialized quadrilateral there is. And we can see it marked here. Parallel sides, right angles, and equal sides. All right, so now let's look at a couple of different examples of some things here. And we'll come back and we'll draw a picture of all this at the end to kind of review. All right, so a couple examples. You might come across some true and false statements as we work today. Things like all squares are rectangles. Is that true? Or is it false? Well, it's true because we just looked at it has all the characteristics of a rectangle, the 4 right angles, and it's a parallelogram. But not all rectangles are squares because not all rectangles have the same side lengths. Okay, example 2. Some rhombuses, also can be said rhombi, either one, do not have 2 pairs of parallel sides. That's false because a rhombus is a parallelogram and parallelograms have to have 2 pairs of parallel sides. All right, now the main thing that we're going to do today is classify our parallelograms. So I'm going to zoom in a little bit here on our different examples. So we're going to have to classify these. We know they're all quadrilaterals, but we're going to have to say, are they parallelograms, rectangles, rhombi, or squares, or a combination? More than one answer is okay. Look at what you've got. All right. While not marked, you could assume that these sides are going to be parallel to each other, and that with the 4 right angles, you have a parallelogram and a rectangle. Okay, and the reason we can know that these sides are parallel is because they're the same length. There's no other way for them to fit together than if they are parallel. All right, moving on to example 4. You notice we've got equal sides, right angles, well, and they're going to have to be parallel. The opposite sides have to be parallel or these aren't going to fit together. So you have a parallelogram, a rectangle, a rhombus, and a square. So you see all 4 answers are okay here. All right, last example like this. Example 5. Notice we have opposite sides are parallel and all the sides are the same length. So that means it falls into the category of being a parallelogram and a rhombus. Now I said we'd come back here and draw ourselves a little picture that kind of how we categorize things. So the quadrilateral is our big category. Then we have a parallelogram. Then under parallelogram we have a rectangle and a rhombus. And then they come together and they both make squares. Now eventually we'll talk about one other category that'll go over here on the side. But for today, these are the quadrilaterals we're looking at. Now to wrap things up, got a couple more examples to look at. So remember yesterday, or well, probably 2 days ago now, we talked about how triangles all their angles add up to 180 degrees. Well, when you have a quadrilateral, you're actually putting 2 triangles together. And so the total angle measures are going to be 360 degrees. So if you are given 3 out of the 4 angles that you need, you can solve and figure out the missing angle measure, just like we did with the triangles, only we're going to have a slightly different numbers to work with. So if we look at example 6 here, you'll see we have a quadrilateral. Some of you may recognize this as a trapezoid, but we didn't talk specifically about those, but it is a quadrilateral. We know that we have a 110 degree, another 110 degree angle, and a 70 degree angle. We've got to find this other missing one. So we can add up what we know, 110 plus 110 plus 70, that totals 290. Then we take 360 minus 290, take our total minus what we know, we found out it's also 70 degrees, so that's our missing angle measure. We can do that over here in our last example. Another quadrilateral. Notice you have a right angle mark, so that means you have 90 degrees, 100, and 145 degrees. Add all those up, 145 plus 100 plus 90 is 335. Take what we know and subtract that from the total. 360 minus 335 gives us 25 degrees. So this missing angle is 25 degrees. So that's a quick little rundown on how to classify quadrilaterals and then how to find some missing angle measures. All right, thank you.